Lesson 7. Problems involving two sets. Let A and B be two intersecting subsets of the universal set U. Then U can be partitioned into four disjoint subsets as follows. Here is a rectangle representing the universal set U, and then two intersecting subsets of U, that is set A and set B. Then the disjoint subset in this Venn diagram are 1, 2, 3, and 4. The subset 1 represents A intersection B. 2 is A intersection B complement. 3 is A complement intersection B. And 4 is A union B complement. Let NA represent number of elements in A. Then the number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. And the number of elements in the universal set U is equal to the number of elements in A union B plus the number of elements in A union B complement. Example 1. A class has 40 students offering mathematics, 30 offering statistics, 20 offering both. 1. How many students are in the class? 2. How many students offer mathematics only? And 3. How many students offer statistics only? Solution. Let M and S denote the set of students offering mathematics and statistics respectively. Then, number of students offering mathematics is equal to 40. Number of students offering statistics is equal to 30. And number of students offering both maths and statistics is equal to 20. Let us represent this in a Venn diagram. Draw a circle representing the set of students offering mathematics, and another circle representing the set of students offering statistics. Clearly, the number of students offering both mathematics and statistics is 20. Is entered first. So enter 20 here. The number of students offering mathematics is 40. And the number of students offering statistics is 30. Then, 1. To find the number of students in the class, we use the formula number of elements in M union S equal to number of elements in M plus number of elements in S minus number of elements in M intersection S. That is, number of elements in M is 40 plus 30 minus 20. And that will be equals to 50. 2. The number of students offering mathematics only is this X. That's this portion. And X is equal to number of elements in M, that's this 40, minus this 20. That's when you remove this 20 from M, we are left with X. So X is equal to 40 minus 20, and that is equal to 20. 3. The number of students offering statistics only is y. To find y, we have to remove this 20 from 30. That is, y is equal to number of students offering statistics minus number of students offering both maths and statistics. That is equal to 30 minus 20, and that is 10. Example 2. Out of 500 car owners investigated, 400 owned Prado Jeep, 200 owned Nissan Jeep, and 50 owned both Prado Jeep and Nissan Jeep. Is this data correct? Solution. Let U be the set of car owners investigated, P the set of Prado Jeep owners, and N the set of Nissan Jeep owners. Then number of elements in U is equal to number of elements in P union N, and it is given that the number of set owners investigated is 500. But number of elements in P is 400, number of elements in N is 200, and number of elements in P intersection N is 50. So using this formula, number of elements in P union N equals to number of elements in P plus number of elements in N minus number of elements in P intersection N. We have 400 plus 200 minus 50. 400 plus 200 is 600. Then minus 50 will give us 550. And this is a contradiction, since we were given that the number of elements in P union N is 500, and we are now showing that number of elements in P union N is equal to 550. So the data given is incorrect. Example 3. If 65% of the people in Akwa Ibom State voted in local government elections and 55% voted in national elections, what is the least percentage of people that voted in both elections? Solution. Let X be the total number of voters in Akwa Ibom State, L be the set of local government election voters, and N be the set of national election voters. Then number of elements in L is equal to 0.65 times X. That's 65% of X. And number of elements in N is 55% of X. That's 0.55 times X. Number of elements in L union N is less than or equal to X. Since X represents the total number of voters in a state, it is possible that not all of them voted in the election. So the number of voters in either local government election or national election should be less than or equal to X. But number of elements in L union N is equal to number of elements in L plus number of elements in N minus number of elements in L intersection N. That is, number of elements in L plus number of elements in N minus number of elements in L intersection N is less than or equal to X. That is 0.65X plus 0.55x minus number of elements in L intersection N is less than or equal to x. And this will give us number of elements in L intersection N. That's when you take minus number of elements in L intersection N to the right, and this x to the left. We will obtain number of elements in L intersection N is greater than or equal to 1.2x minus x. And 1.2x minus x is equal to 0.2x. That is at least 20% voted in both elections. On your own. Number 1. If number of elements in A union B is equal to 60, number of elements in A is 25, and number of elements in B is 54. Find number of elements in A intersection B. Number 2. A market research group conducted a survey of 1,000 consumers and reported that 720 consumers liked product A and 450 consumers liked product B. What is the least number of consumers that must have liked both products? Number 3. In a survey of 400 students in Department X, 200 were listed as smokers, 300 as gum chewers, and 150 as both smokers and gum chewers. How many students are neither smokers nor gum chewers? Number 4. A market research group conducted a survey of 500 consumers and reported that 360 consumers liked biscuit and 225 liked bread. What is the least number that must have liked both products?